Shannon invests $7,300 in two different accounts. The first account paid 10% simple interest. The second account paid 12% simple interest. At the end of the year, she earned $794 in interest. How much was invested in each account? So this is a money problem. What this is like, this is like the tickets. Remember when we had the adults and the children and they were buying tickets to the whatever, the movie or whatever, the zoo or whatever it was? This is what this is like. This is what an investment problem. So it's not a mixture. My point is it's not a mixture because in the end, you're not taking a 10% account. You might wonder, how do you know it's not a mixture, Mr. Trent? How do you know we shouldn't use the beakers, the buckets? It's not a mixture. We're not going to use the buckets because what happens in a mixture problem? You have an original, whatever it is, solution, and a second solution, and then a final product. See how we have no third percentage here? See how there's only two percentages, not a third? So look back at number 5. Let me show you the difference between a mixture and a non-mixture. Look at number 5. 40%, 60%, and then the final mix, 58%. That's a mixture. You've got a final product that's between the other two. Or even up here in the money. This money one was a mixture. You can have money and be a mixture. First off, it says the word mix right there. This is I'm going back to number 4. Look, but here's how you know. The first kind of coffee is $8.60 per pound. The second is $14.10 per pound. And the third is $11.13 per pound. Per pound's like percent. It's the quality of the mix. So those are mixture problems. And then you have the final amount. Okay. Whereas on number 6 here, this is not a mixture problem because there's just the original percent and the second percent. And you think, well, yeah, but what that's something for? Yeah, that's not a percentage. That's money. That's final money. That's just like the adults and the children tickets, right? We would say, you know, there's a bunch of people going to the zoo, and you know the adult tickets are $10, the children tickets are $12. You know, in the end, this is how much money. That's what this is like. It's just like that. So it's not a mixture. Okay. So what's our first equation? First equation is going to be total invested. What do I mean total invested? Well, the first account, I'll call it F. You could do X and Y, but first account plus, and then the second account, right there, second account, plus second account. You can use X and Y if you want. First account plus second account adds up to be $7,300, right? Because Shannon invested $7,300. That's what it says. Shannon invested $7,300. $7,300 Shannon invested. So that's the amount of money Shannon, and that's the total amount. So however much money she put in the first account plus however much money she put in the second account, or I guess Shannon could be a man or a woman, anyway, whatever, Shannon. And then that adds up to 7,300, right? So however much she put in the first account plus second account totals the 7,300 that she invested. And then the second equation is all about the interest earned. So in other words, in the first account, she earns 10% interest. So however much money she puts in the first account, she gets 10% of that. So 0.10 F. Remember, whenever we have a percentage, you got to change it to a decimal. Move the decimal back 2 places. The second account, 12% interest, 0.12 times the second account. And that interest, at the end of the year, she earned $794 total interest. There's our second equation. There we go. Is that making sense? So you multiply the amount she put in the first account times the percent she earns, plus the amount she put in the second account times the percent she earns to equal the total amount of money she earned in interest, $794. All right, so now we have two equations with two letters. You know what to do. Let me bring this up here. I'll go F plus S equals 7,300, right? Subtract S from both sides. Boom, boom. Down the F equals 7,300 minus S. So grab that, plug it in right there. F equals 7,300 minus S. And so I'm going to plug in 7,300 minus S right there. So you get F alone in the first equation, plug it into the second. Good there. Now we distribute. So 0.10 times 7,300 is 730 minus 0.10 S plus 0.12 S equals 794. And so now we're wanting to solve this. So let me bring in the wall of separation right here. Okay. So let's see. This and this will combine together. So it'll be 730. Let's put that down. And that'll be plus 0.02 equals 794. So these two combined, it's 0.12 minus 0.10, like 12 cents minus 10 cents leaves 2 cents, 0.02. S, that's an S. My S's start looking funny. All right. Now I subtract the 730. Like that. And I get 0.02 S equals, what's that, 64. We're almost there. Divide by 0.02, boom, boom. S equals, let's see, 3,200. I'm pretty sure that is 3,200. Let me double check my calculator here. Yeah, 3,200. Okay, so we got S. That's how much was invested in the second account, 3,200. Now what do? You know what to do. Now we grab that and we plug it in anywhere we want. So let me bring it over here. And we're going to plug in S equals 3,200. Where are we going to plug in? I'm going to grab the first equation. Looks like the easiest one. Bring it on down. And that one's F plus S equals 7,300. Plug that in right there. 3,200 in for S. F plus 3,200 equals 7,300. And then subtract the 3,200 from both sides. Boom and boom. Like that. And bring that F down. And that's what, 4,100? We got F and we got S. There it is, first and second. So the first account, which is the, oh, you can tell right here which is which. The first account is the one that's 10%, and see how the second account is with the 12%. Just look at my equations, you can tell. The 10% is the first account, the 12% is the second. So the 10% first account, 4,100. So I'll put that in up here. 4,100. And then the second account right here, 3,200. 3,200. All right, so let's recap what just happened there. Well, basically, when you get these investment problems, this is an investment problem. It's just like the adult children tickets. It's not a mixture. It's not a mixture because we don't end up with a final percentage, right? We just have a 10% account and a 12% account. We don't have, together they mix together to be an 11% account. No, we don't. That'd be mixture. This is not a mixture. We just have the final earnings. So that's just like, adults and children going to the movies. We have the final amount of money the theater made, right? This is like that. So no beakers, no boxes, just two equations. So the first equation is first account plus second account is $7,300. That's a total amount invested. That's like number of adults plus number of children is total people. Then the second account is we multiply. The first account pays 10% interest. The second pays 12. So 0.10F plus 0.12S equals the total interest, $794. And then we just solve it. You know how to solve two equations with two letters. Take the first equation, get one of the letters alone, plug into the second, solve for that letter, and then plug back in, get the second letter. And so there we go.